Okay, folks. Hey, we're going to do some proofs today. The good news is we only have 5 problems in homework today. Bad news is there are 5 proofs. I can help you out with that. This is not going to be that difficult. I don't want you to feel all overwhelmed. Look, I'm going to do example 2 from the course, material that I've been kind of preaching about, right? So I went into the course and here's example 2, and they've got some drag and drop options, that we can put up here. But I want to make it clear that today on your homework, you can do the assignment digitally, like I'm showing you right here, or you can do the assignment straight from the textbook. And if you're doing it from the textbook, then you're going to copy, a 2-column proof down, you copy the drawing down, and you'll just fill in the information here. If you're doing it from McGraw-Hill, I still want you to put the 2 columns down in your notebook, and I still want you to put a drawing down. And you never copy this stuff up here down because it's going to end up in your proof. All right. So let me make that clear. Whether you're doing it digitally or you're trying the problem right from the textbook, I still need you to put the drawing down, and then you're going to mark up the given information. So it tells me that we've got some parallelograms here. So I'd start putting some parallel symbols on the opposite sides. That's what a parallelogram means, right? So I'm trying to just get down what I know about parallelograms here. Now, you notice I used one arrow here because, hey, look, these I said were parallel to each other, and these 2 sides are parallel, so all 3 of them would be parallel. So I'm going to use the same little arrow that I used down here, okay? Then I'm going to use 3 little arrows here because this side is parallel to this one, but I'm not guaranteeing it's parallel to anything else. So I've marked up my given information. The next thing I like to do is look at what I'm trying to prove and make a plan in my head. Like, how am I going to make that happen? So I don't mark them equal. I just put little dots on what I'm trying to get equal. So HJ congruent to ML. Well, where the heck is HJ? It's way up here. And where is ML? Oh, it's way down here, right? So those are the 2 sides that I'm trying to get congruent to each other. Well, if this is a parallelogram, right, these 2 sides here would be equal to each other. And if this is a parallelogram, these 2 sides would be equal because opposite sides are congruent, right? So then by the transitive property, this side would be equal to this one. It's like if you're the same age as Bob and Bob's the same age as Sue, well, then you're the same age as Sue. That's the transitive property right there, okay? So here's what you do. You've made your plan in your head. You know you're going to use the transitive property and all that jazz. Now we just have to set up the proof correctly. So what I always do is I always put the given at the very top of my proof. It takes some load off my brain, like saying, oh, I'm just going to use the given information when it's, when it's perfect time to use it. It doesn't matter. You can just put it in your proof. You're going to be guaranteed to score some points on the test if you put given at the very top of your proof, okay? The next thing I want to assure you of, you'll score some points if you just straight up copy the proof part, but you don't put that up very close to the given because there might be a whole bunch of steps between the given and what you're trying to prove. So I'm going to grab the proof part and I'm going to give myself some space in between the given information and what I'm trying to prove. Now, look, you never just put the word prove down here. We're not sure what the reason for this being true is quite yet. Well, we brainstormed in our head. We think it's a transitive property, but I always wait to put down my reason because I might change my mind. All right. So what did we say? We said that HJ is congruent to PK. So this is the next thing we do in our proof. We say, okay, I'm gonna summarize what I was thinking, but I'm just gonna write it down now. So HJ is congruent to PK, and that's by if you have a parallelogram. If you have a parallelogram, then opposite sides. Oh, that's too messy. I can't take that. That's no good. Opposite sides congruent. Okay. Now, if it makes you uncomfortable to abbreviate that much, then write out, the whole word, all that kind of stuff. Next thing I'm going to say is PK is congruent to ML. So PK congruent to ML. And same reason as above. So I don't rewrite all that stuff. I just put down same and a little arrow like right up above. See, it's the same as this one right here, right? Now I'm using the transitive property. Let me see if I can make this clear. See, this is what we wanted on the left side of the equation right here, right? This is what we want on the left side. And we wanted on the right side ML. And look, see, ML is going to be on the right side, but we don't want PK involved. So it's like you're the same age as Bobby and Bobby's the same age as Sue. We can skip Bobby altogether and just say you're the same age as Sue, right? So that's called the transitive property. Let me put that right down here, transitive property. And sometimes you'll leave, more space than you need. So I don't know, that's kind of uncomfortable sometimes, but whatever it is, what it is. Transitive property. And we're done with our proof. As a beginner, you might feel uncomfortable with that. You're like, how do I know I'm done? Well, we've got our final statement down. We made it there, and you might not know if you have enough like justifying information up above. But I want to assure you that on the test, you're going to score points for putting the given down. You're going to score points for putting the prove part in the right place. You're going to score points for marking up your drawing. So you don't have to get every single little step in between correct to get a good score. Not you're not going to get a perfect score if you miss some stuff in the middle, but you can get a good score still by understanding how the proof gets structured. All right, and the general process. So I hope that makes it clear. Today on your assignment, you can do the problems from the textbook, or you can do them just on McGraw-Hill. So if you're doing them on McGraw-Hill, right, it wants you to drag and drop. So I put the given up where the given belongs. I put the opposite sides in a parallelogram congruent where they belong. And then I put the transitive property where it belongs. And you're going to check your answer. And you get some feedback that way, which kind of feels good. However, you have to do it exactly the way the author tells you to do it. And just to try to make this as clear as possible, remember, to get to our textbook, you go to, basic McGraw-Hill here, and one of them says student edition textbook. And our problems are in lesson 2.2, right? So here are three of them right here. It's 15, 16, and 17. The other two are back here on page 71. We're doing 6 and 7. So we're doing 6 and 7 from page 71. And we're doing 15, 16, 17 from page 73. If you feel like you know what you're doing, go ahead and start on the homework right now. If you're like, oh my gosh, proofs are completely intimidating, stick with me and I'll get the first problem set up with you, okay? So here's what I would do on the first problem, number 6, okay? It's number 6 from the textbook, but it's number 1 in McGraw-Hill. It's just because I skipped 1 through 5. We did those yesterday. I hope that makes sense. So I'm going to take a picture of the given information, and I'm just going to put it right in the first line, right over here. That's my given, right? And then I write given down over here to the side. And I've scored some points by putting the drawing down. And we're going to mark up the drawing. So it says we got a parallelogram in here. So let's go ahead and put little arrows on the sides. Opposite sides are parallel to each other, right? Boom, boom. We got all that taken care of. Now it says we want to prove CA is congruent to CG. Oh my gosh, where's that at? CA. Oh, no, that's given. That's not what we're trying to prove. CA, is equal to CG right down here. And we're trying to prove, I haven't put that down in my proof yet. So let's take a picture of that guy and drag it down to the right spot. Okay, so here we go. We skip some space. We put that guy way down there. And do not write anything over here quite yet. We don't know the reason quite yet. Okay, so let's brainstorm a little bit. If I know this side is equal to this side, and I'm trying to get some angles equal to each other, let's go look at where the angles are, okay? Let's look up here and put some dots. So where is BDH? BDH is right here, okay? And angle G, oh my goodness, angle G is way over here. That's not inside the parallelogram. So let's brainstorm this. Why did they tell me that this side is equal to this side? Well, if we have an isosceles triangle, let's put a little isosceles triangle here, okay? That means two sides are equal. I don't know if you remember this or not. Then the base angles would be equal. So if we had an isosceles triangle like this, the base angles are the ones that are across from the equal sides. I hope that makes sense. Remember how we had like the smaller angles across from the smaller side? Now we're saying if we have two equal sides, the base angles would be equal. So maybe you've forgotten that. that property, or maybe your teacher last year didn't talk about it at all. So, okay. So let's look. This, where I got this little red dot, is going to equal where I've got this nothing up here, angle A, right? So angle G and A are going to be equal to each other because the isosceles triangle idea. The triangle is rotated over on its side. These are the two equal sides, right? And over here, I have these marked as equal. I hope that's okay with you. All right, so I know these two are equal to each other. Oh, wait, opposite angles in a parallelogram are equal. So we're going to be able to say these two are equal. And then we're going to say the transitive property, like if D is equal to A and A is equal to G, well, D is equal to G. Okay, so right down here, this I'm pretty sure this is going to be the transitive property right here. If you're so confident, well, let's put it down. Like if I've convinced you it's the transitive property, put it down. Okay, now McGraw-Hill on the computer, they might call it substitution. Substitution and transitive are really the same thing. All right. So coming back up here, let's see, what did I say? My brainstorm was, I'm going to say D is equal to A. So I'm going to say I can't just say D because there's lots of angles here. There's one here, one there. There's the whole straight angle. So I'm going to say HDB. So I'm going to say angle, and you know what? Instead of going HDB, I'm going to go BDH. I'm going to go BDH to make it look exactly like the left side here. So I'm going to go angle BDH is congruent to, not important. You could say HDB, same thing, right? BDH, HDB are same thing. So this angle here is equal to angle A. I had in my head, in the past, I've told people you could just put a little 1 in here. If you put a 1 in there, then you can call this angle 1. All right. So let me undo that 1 because it's not given to us and I don't want to go there quite yet. So this angle is equal to that one. That's because if parallelogram, then opposite angles are congruent. Then opposite angles congruent, right? Now let's go with the A is equal to G bit. So angle A is congruent to angle G. I can use one letter there because there's only one angle. And that's this thing. This is the isosceles triangle idea. If I have an isosceles triangle, then the arrow means then. You don't have to write then. You can write this little arrow. That's what is used in college level logic and all that kind of stuff. Then the base angles are congruent to each other. So I'm going to mark the base angles equal. Okay. Now I've got the transitive property and I'm done, right? So like if you are the same age as Bobby and Bobby is the same age as Sue, then you're the same age as Sue. That's what we're doing right here, the transitive property. So I got a lot of extra space. Sorry about that. I hope that makes sense. This is how you do your homework today. Or you go to McGraw-Hill and you do the little drag and drop business. Thanks for watching all my videos today.